Hi, and thanks for joining me. My name is Scott Trump. I'm the founder and chief storyteller at Deep House AI. We're developing a couple services that use artificial intelligence to enhance and evolve the changing world of B2B sales. And today we will focus on the forecasting piece. This is intended as a technical presentation to describe the logic and mathematical underpinnings of our approach, and I will try to cleverly use quantum physics to explain a bit of our premise. Even though these ideas can be broadly applied, I tend to think of this in the context of what some call complex B2B sales. It's a fairly popular term, generally focused on engagements that are large deals, complex deals, long decision cycles where there's a lot of people that have hands on the decision process. Tech is not much good unless it helps us with some things. Here are some sobering statistics about the modern world that salespeople sell into. Too many of them miss their quota, and they get to spend only a fraction of their time working with customers. And buyers are engaging them later and later in the decision process, as there are so many resources to self-educate these days. On the topic of modern sales forecasting, we definitely need the help. 60% of forecasted deals don't even come in. Of the ones that do come in, only 28% actually match the forecast. That means only 11% of a forecast is accurate. In a world where leaders want increasing confidence and reliability in their forecast, this just doesn't work anymore. For those of you not that familiar with sales forecasting, here is a simple graphical representation of just one deal. Riley is one of your salespeople. Riley has a customer named Gene Co. And on January 7th, they forecasted in their CRM that the Gene Co deal will close on a certain date for a certain dollar figure. Now, if you take a step back and look at all of Riley's deals throughout the year, here, each deal, each customer perhaps is represented by a different red dot. This is what people think and hope a forecast looks like. A bunch of deals evenly distributed across discrete dollar values mapped to discrete dates. But if you look at real world forecasts as they're entered and tracked in CRMs, this is what it actually looks like. Salespeople tend to pick dates at the end of the quarter because that's a little safer. And because we don't have crystal balls to figure out how much the customer is going to spend 3, 6, 12 months in the future, we tend to pick Goldilocks values, small, medium, and large. And if we drill back into the one Gene Co deal, you'll find with each successive, usually weekly forecast, these metrics, these values move around. Forecast deals get pushed out. Maybe they're a little sooner. Sometimes they get to be of higher value. Oftentimes they are forecasted of a lower value. And this tends to change every week through the deal cycle. The big takeaway here is that forecasted information, and I'm just using deal size and close date here as two examples, the more popular, does not exist as discrete values. Because they move around and change, they're actually variables, though they do fluctuate within certain predictable boundaries. Okay, so let's inject a little quantum physics fun. Subatomic particles, since the time of the ancient Greeks, all the way up through Newton in the early part of the 18th century and Rutherford in the early 20th century, were conceived of as discrete particles, sort of like little marbles that were either stuck together or revolving around each other. As easy and persistent as that simplistic model was, in 1925, Erwin Schrödinger, probably most famous for Schrödinger's cat, blew it all up with the Schrödinger equation. He replaced that old model, that simplistic discrete model, with what things really look like at a subatomic level. They look like a probabilistic wave function. And even though that simplistic model has been replaced for the last 100 years, people still tend to think of subatomic particles as marbles. Which brings us back to our forecasting, because that notion of utilizing outdated simplistic models to represent something that's actually mathematically much more complicated persists. This is the accurate representation of forecasting data as probability distributions. And this is a well-known concept in statistics. What you're looking at here is called a gamma distribution. The common bell curve is actually an example of a gamma distribution, and we're using it here to represent a pretty foundational statistical concept called a maximum likelihood estimation. So using this core concept, we actually take those two metrics, those two variables, deal size and close date, of which there can be many, and we look at them in terms of probability now. Probability versus deal size, probability versus close date. If we leave behind the fallacy that this data exists as discrete values, we open up a world of possibilities with this new representation, because there's a lot more to look at, a lot more to measure, a lot more to analyze in this mathematical model. And remember, what you're looking at here is the probability of just one variable. Imagine the insight you can get from blending all these distributions and variables across all of Riley's opportunities, and then at a higher level, integrating all the sales teams across the entire pipeline. Well, we need artificial intelligence for that level of analytics and insight. But there's so much more insight to be derived from the modern customer journey, provided you're using the right data, the right models, and the right philosophies. What you're looking at here is the typical and historical important information in a CRM about a forecast, close date and deal value, as we discussed. But if you do it right, there's so much more to pull out of this. The changes in how customers buy and consume products and services is becoming so obvious. The move from offline to online, products to services, software to SaaS, buying things and licensing things to paying by the drip, economics models that move from expenditure to consumption. Sales is no longer about a discrete big order on a discrete day. It's about a continuous cultivation of your customers to gain their loyalty and growth. Given the right tools, you can look so much deeper into the customer journey, noting that each one of these can be represented with a probabilistic distribution. So you can certainly look at things that happen around spend, a certain amount of spend in a certain day, or actually more popular, how spend is trending across the account, across certain products. And progress isn't just measured by dollars. You can look at when meetings are happening, when contracts are signed, different usage thresholds or usage milestones. And you can also then look at the duration in between all of these things. It can all be predicted. In complex B2B sales, all deals and customer relationships start with a forecast. So imagine the depth of insight, the opportunity to optimize and accelerate, and the added value to your CRM by using quality inputs if you could go this deep, simply by representing the real world with accurate models and reliable data. And a little cleverness by Deep House AI, of course. Deep House AI is a technology company working towards finding the right balance between man and machine, allowing people to do what they're best at and machines to do what they're best at. We're developing a service called Fivecast that leverages historical data and salespeople's real-time insight to deliver predictive forecasting. Leaders get reliable, consistent detail on where the business is going, and salespeople get to spend more time with customers. So thank you for your time today. I encourage you to go to our website to learn more. We have another product called Waypoint that's focused on guided selling. And keep an eye on this YouTube channel for more content very soon. Thank you so much and have a lovely day.